In question number 5, we're given a pair of functions and we want to find f plus g, f minus g, fg, and f over g. And for each of those, give the domain. We're given the functions f of x equals 3x plus 5, g of x equals x squared minus x plus 4. To find the first one, which is f plus g of x, we want to find f of x plus g of x. We're going to take the f of x function and substitute it in, which is 3x plus 5, and the g of x function is x squared minus x plus 4. By combining like terms and starting off with the greatest exponent, x squared, we're going to simplify this. X squared, when we combine 3x and minus x, that is going to give us 2x plus 2x, and then when you combine the constants 5 and positive 4, combine those to get a plus 9. That is our f plus g of x. Now we want to find the domain. The domain is everything that you can plug into this function. There are no restrictions because no matter what number you choose, a positive number, a negative number, anything is going to work as a value you can plug into this function as part of the domain. So the domain is everything from negative infinity to positive infinity. Okay, the second part is to find f minus g of x. F minus g of x is the f of x function minus the g of x function. When you substitute in the f of x function, you get 3x plus 5, and substitute g of x function. I'm going to put this in parentheses, minus the entire g of x function, x squared minus x plus 4. Going to first distribute the negative sign to g of x, so you're going to subtract everything in there, which gives us 3x plus 5 minus x squared plus x and minus 4. Simplify by combining like terms to get negative x squared as the leading coefficient. 3x plus x is 4x, and plus 5 minus 4 is a plus 1. And check our answer. The domain of f minus g of x is all real numbers here as well. You can plug any number into this function and get a value out. This also is negative infinity to positive infinity. And also whenever you have infinity in your interval, it's going to have a parentheses. Okay, for the next one, we want to find fg of x. Fg of x is where you multiply f of x times g of x. And that is f of x times g of x. Take the whole f of x function, which is 3x plus 5, and you're going to multiply it by the g of x function, which is x squared minus x plus 4. Let's do this by first multiplying each of these terms by 3x. It's kind of an extension of FOIL where we first multiply everything times the first term. That's 3 multiplications to get 3x times x squared is 3x to the third. 3x times this minus x is minus 3x squared. 3x times plus 4 is plus 12x. And then we're going to multiply everything by the last term, 5, to get plus 5x squared minus 5x plus 20. We're going to combine like terms to get 3x to the third, and then the two terms that have an x in it, negative 3x squared and a positive 5x squared, is a positive 2 plus 2x squared. The 12x and minus 5x is plus 7x, and then plus 20. Three x to the third plus 2x to the second power plus 7x plus 20 is our answer. And then in terms of the domain, everything you can plug into this number. This has no restrictions. You can plug everything in for x. You can plug in 1, 2, -1, -2, -1,000,000. So the answer is from negative infinity to infinity. Okay, the last part of this is to find f over g of x. To find f over g of x, this is where we're going to take the f of x function and divide it by the g of x function, which gives us in the numerator 3x plus 5 over x squared minus x plus 4 in the denominator. This cannot be simplified. You don't want to try to cross anything out here. You can't cross out anything in a fraction if it's next to a plus or minus sign. The numerator is 3x plus 5. The denominator is x squared minus x plus 4. And we can check our answer. To find the domain, we do have to be careful when we're dealing with a function that is a rational function where you have variables in the denominator. Whenever you have a fraction, you can never ever have a 0 in the denominator. So if we set up x squared minus x plus 4 cannot equal 0. We want to know, is this ever going to equal 0? If it does equal 0, then that is a restriction on our domain. Looks like this cannot be factored, so the way you would solve this equation to find out where it's equal to 0 is by using the quadratic formula. The quadratic formula, again, is x equals negative b. Hope you have this one memorized. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And if we plug in the negative b, opposite of b, and b is negative 1, negative b plus or minus the square root of b squared minus 4ac all over 2a. And when you simplify this, you get 1 plus or minus the square root of 1 minus 4 times 1 times 4. It's 1 minus 16 is a negative 15 over 2. Now, hopefully you recognize that this square root of a negative is an imaginary number. So this has no solution. There is actually no values of x that you plug in that will make this 0. So this is all real numbers is a solution. Everything from negative infinity to positive infinity is a solution. There are no restrictions on the domain. At times you may find that there are restrictions and you want to indicate that. Nice work. For number 6, we are looking at composition of functions. Whenever you see that little O right in the middle there, that's a composition. In this case, we have f of x is x minus 1 and h of x is negative x minus 2. We want to find f of h of 4. That's how you read it, f of h of 4. And the way you find f of h of 4, you can do this a couple ways. You can find f of h of x, the general form, and then once you simplify that, you can plug in 4 to get your answer. Well, f of h of 4 is another way to write that is to write f and in parentheses h of x. That means you're going to put the entire h function into the f of x function. We're going to take all of this and plug it into the f function. So this is the same thing as f of h of x function is negative x minus 2. Plug that into the f of x function. Wherever you see the x here, you're going to replace it with the x, negative x minus 2. So it's going to be negative x minus 2 and then minus 1. When you simplify this, you get negative x minus 2 minus 1 is minus 3. That's our general f of h of x. Now we want to find f of h of 4. F of h of 4. We can plug 4 in here and we get negative 4 minus 3, which is negative 7. That's one way of solving this type of composition of functions. Another way, which you may end up liking better, is to first take 4, plug it into h function, f of h of 4, as you first take the 4 and plug it into the h function. So let's find h of 4. That is negative 4 minus 2, and we get that is negative 6, h of 4. And then whatever we get out of here, we're going to plug that answer into f. So find f of negative 6. Plug negative 6 into the f of x function for x and subtract and you get negative 7. So either way you do this, you can find the composition of functions.